Hello, welcome again. We are solving some questions of applied mechanics. The topic is friction. Question number 5 is a bullet of mass m travels at a very high velocity v as shown in the figure and gets embedded inside the block of mass capital M initially at rest on a rough horizontal floor. The block with the bullet is seen to move a distance s along the floor. Assuming mu to be coefficient of kinetic friction between block and the floor and g the acceleration due to gravity, what is the velocity v of the bullet? Option A, m plus capital M by m small m root 2 mu gs. Option B, m minus m by m root 2 mu gs. Option C, mu m plus m by m root 2 gs. Option D, m by m 2 mu gs. Okay, here it is given that the mass of bullet is small m and mass of block is capital M and initial velocity of bullet is v. Suppose v1 is the final velocity of the system when the bullet gets embedded in the block. Okay, and after this after the gets embedded in the block starts sliding on a friction on a floor which has friction. Okay, so first of all we have to find out this v1. Okay, v1 is velocity, combined velocity of bullet and block when the bullet strikes the block. Okay, as the block is initially as block initially is at rest. Okay, so total momentum will be only the momentum of this bullet. So total momentum initially is mv, and after striking the bullet, sorry, block and bullet attains velocity v1. So final momentum is m plus m into v1. So v1 will be your mv divided by m plus m. So v1 is your velocity. v1 is your velocity after the block and bullet uh, make a combined system or at the start of combined system. Okay, and when this combined system starts moving on the frictional floor, so there will be retardation in the system. Okay, or in the block and bullet, and that retardation is due to friction force. Okay, so now when the block is moving on the floor, the forces acting on the block are weight of the block, that is m plus m by g, and Rn is normal reaction of the on the block due to load, and that is F are the friction force acting on the block. So these three forces are acting on the block when the block is moving on the floor. Okay, as this system is in motion, so or this is your dynamic problem. So to convert it into a static problem, we will introduce an inertia force. Okay, as block is deaccelerating in this direction, as block is deaccelerating in this direction or accelerating in this direction, block is deaccelerating in this direction or accelerating in this direction, and inertia force act in a direction opposite to that of acceleration. So as there is a deacceleration in this direction, acceleration in this direction, so inertia force will act in this direction. Now by introducing Fi, we have converted this dynamic problem into static problem. So now if it is a static problem, then we can apply the static equilibrium condition. So the forces in y direction and forces in x direction should be 0 net forces. So summation of Fy should be 0, summation of Fx should be 0. So we can say Rn is equal to m plus m g, and as force of friction is directly proportional to normal reaction, so Fr will be your mu Rn or mu plus m into g. Okay, and if A is the acceleration, then inertia force is m plus m into a, or and that will be equal to Fi will be equal to Fr. So it will be mu m plus m into g. Okay, so acceleration comes out as mu g, and acceleration is in this direction. Okay, so if we consider deceleration, then it will be negative of acceleration. So that will be minus mu g, or retardation. Okay, so now we can apply v square minus u square is equal to a. Okay, so here v is your 0, final velocity is 0. Okay, and a is minus mu g. Okay, and so from minus and minus, uh, minus minus will cancel out, so u square will be your mu g, 2 mu g s. So because we are considering this, as block is moving in this direction, so there is deceleration in this direction, and value of deceleration is minus mu g, and final velocity being 0, initial velocity being u. Okay, so u will be your 2 mu gs, or as u is your that v1, that is initial velocity of block and bullet. Okay, so u is equal to v1 is equal to 2 mu gs. Okay, or we can say v is equal to v1 is equal to mv by capital M by m. So it will be m square v square divided by m plus m square. Okay, putting the value of v1 or u, or so it will be equal to 2 mu g. So v will be equal to uh, m plus we take root m plus m root 2 mu g. So answer is option A.